Hi, my name is Bruce Ellingson, President of Diligence Incorporated and author and creator of the Citizen M-Series programming training course. My background consists of more than 25 years of experience in producing precision machine parts, from toolmaker to a CNC machinist and CNC programmer. As a result of my 15 years of programming and machining skills, I became a Citizen Applications Engineer for Productivity Incorporated, which, as you know, is the largest machine tool distributor in the upper Midwest. Part of my duties at Productivity were creating training manuals and providing on-site training programs for production staff. I then started Diligence Incorporated to provide training materials and programs for the most prestigious shops, some of them containing dozens of M machines. So with my technical writing skills, a new video camera, and editing equipment, I set out to create this training program. This video series has received wide acclaim from people such as Brian Such of Mayor Betty Citizen Chicago and CNC Swiss machine companies around the United States, and by the many people who have learned programming while watching them. Because Citizen wanted the M machine to create virtually any Swiss part imaginable, it had to be very configurable to any process, making it very powerful while making the programming language extremely complex in the process. For this reason, I decided to make the training program more easily understood. This course goes through the necessary information to learn the capabilities of this complicated machine. In the past, learning how to program this machine was done with either on-the-job training, machine tool distributor training, or through consultants such as myself. These training types are good, but too extensive in the amount of material that has to be covered and memorized. This requires shops to expend large amounts of money on training that is quickly forgotten days or weeks after the training has taken place. This challenge has created a need for a repeatable course. Studies have shown that as much as 90% of learned material can be lost over time without a system of reference material that can be accessed as required. Being able to refer back to an on-site training program is important in maintaining and improving the skills of programming and production personnel. Diligence has met this challenge with this video training system. Now, nothing is stopping the employer from replaying the video training course for their people to refresh their skills. Many people need to see something more than once before it sticks. Also, oftentimes the students don't realize what is important to remember at the time of the training. A video training course allows them at their own convenience to pull the disc off the shelf and re-watch the video for items that they need to look up and study. Rapid searching is accomplished through an extensive menu found on the DVD format. Another benefit of the Diligence training is the type of course it is. It has been created to simulate a hands-on experience by using more than 2,500 different scenes. These highly descriptive scenes range from quality solid model renditions to extensive live machining footage. This is a true advantage over trying to see through a layer of cutting oil spraying against the chip shield. These videos show at extreme close proximity what is really going on inside the enclosure. To enhance the visual experience, the training includes narration with extreme clarity and easy to understand terminology. But most important of all is the information that is given through these 7+ hours of narration and visual images. Disc 1, with a runtime of 153 minutes, contains information on the program structure and the format of the program and how the different sections of the program work together.
The next line of code will set up the coordinate system of your stock, the Z coordinate system and the X coordinate system. This is done with a G50, which is a coordinate shift command. It is used for changing where your 0 of the part is on the Cartesian coordinate system. It will be explained more thoroughly in the programming portion. Next, a mode will be called up for the process that was chosen for your part. The back spindle work for the turret is usually always programmed in the subprogram like this. The basket dump is done here also. The next item in $2 is the pick-off codes that basically will just get the turret out of the way so that the back spindle and the main spindle can work together.
It also incorporates the M machine's capabilities and pick-off procedures.
With the gang tooling, you can do turning operations on the main spindle side. While turning, you could be drilling into the center of the part with a turret tool at the same time. You can use the gang tool live tools to drill or mill on the part. Let's go through some processes you have to think about when picking off the part. Do you want to use an extended nose collet, or do you want to pick off on a strange shape of the part? Or is your part very delicate, needing extreme care in spindle RPM and technique? You wouldn't want the part to twist in half. These processes will need to use the spindle synchronization mode. This mode ties the two spindles together. When I say ties them together, the two spindles run at the same RPM very accurately.
Disc 1 also goes through information on intelligent ways to process your part and things to look for to save cycle time.
When designing your process, you must ask yourself a lot of questions. Some of these would be, how should you divide the program up as far as the back spindle work and the main spindle work is concerned? Which end of the part should come out of the guide bushing first? Or what end of the part is the back spindle going to hold on to?
It also contains every M code the control uses from M1 to M127. Spindle M codes.
These 3 codes are rotation commands for the live tools in the turret, the S4 spindles. These spindles are driven by 2 face gears in the turret. M83 is forward rotation. Written M83 S4 equals 6700. The C-axis, when going in a positive direction, is going in the counterclockwise direction also. Turning on the main spindle is written like this. M3 S1 equals 4000.
Covering spindle fluctuation.
It saves the machine from spindle damage and maybe fire. There are times when this detection can hinder operation though. It must be shut off for spindle synchronization, for constant surface feed per minute, and for tapping.
Disc 1 finishes with how tool calls work and how you can save time while changing tools.
Is X 3 inches with the other tool and call up the Q1 for the next tool. And instead of going to the safety diameter above the stock and then moving over, it would go at an angle from the X 3 inches and go to that tool's position point.
Disc 2, with a runtime of 104 minutes, contains the G codes G0 to G67. Incorporating information on feed commands.
Using the G1 command with more than one axis, both axes start out at the exact same time and end at the exact same time. This makes very accurate angles. You will call up the type of feed command before you start the feed commands. This feed rate will be either in IPR, which is inches per revolution, which is G99. IPM is inches per minute, G98. DPM, which is degrees per minute, which is G98 also. Use this when using the C-axis or when using the turret A2 axis. After a tool change, the first G1 command line must have a feed rate with it.
This disc includes an extensive section on virtual G12.1 milling on the gang and from the turret, with step-by-step instructions.
The G12.1 is a special mode used for milling with the turret on the part in the main spindle. The G12.1 is a machine option. The turret has the X2 axis and the Z2 axis for milling, but it does not have a true Y axis. The G12.1 command creates a Y axis by using the C axis and the X2 axis together. Center is X0, Y0. Number 4, all movements are in radius. In other words, do not program the X-axis numbers with diameter programming.
Another G3 is called up, then another linear move to the next G2 arc, then that arc. Now we are in the positive X and positive Y quadrant. After a few more move commands, we are in the X positive and Y negative quadrant. Then, when we are done with the last arc, we feed back to the start and shut off our comp with a G40 command. Then we rapid our tool out of the part to Z negative 30 thousandths. And then we shut off the G12.1 with the G13.1. Always
Have to be in the G16 plane selection, which is the cylindrical machining plane. This lets the machine know what direction to turn radii and how to run the compensation. You would be programming X, C, and Z, or X, Y, and Z, depending upon your machine's parameter. Number 5, the starting location will be opposite sign once started in mode for C axis.
Disc 2 also goes through single point threading and tapping with the G32 command.
We will now go through a tapping routine to help you understand how the G32 works for tapping. This is the type of tap holder you will need for tapping on this machine. It is what is called an extension tap holder. The tap can be pulled forward to compensate for the machine reversing. To start out programming your G32 thread, make sure you're at the correct speed. In other words, put a dwell after the speed is called up to let the speed settle down from the tool speed used. 1 or 2 seconds should suffice. Put your tool to a safety location with a GO. Then go into your G32 command with your starting axis being always the X axis. Also make sure you put the correct feed rate for your part on that line.
This DVD contains instating cutter compensation with G41 and 42.
Turning tools that have radii on their tips, it is sometimes easier to program them with tool nose radius compensation. This is because a tool with a radius cannot follow the true shape of the part without either changing the program numbers or using compensation to move the radius tip to the correct spot. G42 is compensation right and used for facing the front of the part going down. As the tool is going down the face, it is on the right side of the part. Right is G42. 4 is for front turning. 5 is for face grooving. 6 is for internal profiling. 7 is for back face grooving. Make your dummy move feed at an angle down to, let's say, the center of the part, and in that line you would have a G41 because now your first move will be feeding up the face.
Coordinate system setting through the G50 command, which is explained in great detail.
Next, we put in our program the shift we want. Since the shift is an incremental shift, we must use the incremental letters for the axis we are shifting. We are shifting in the Z direction, so we will use the W incremental axis letter. Mainly because of the diameter of the spindles and how the machine was constructed. The shift for the live tools is 590 thousandths and 5/10, which is 15 millimeters in metric. Boring bars always have their tips pointing down when on the turret. This is so all your programming would be positive, meaning you would have positive X-axis callouts and not negative. Boring bars need an extra U shift to go from the center line of their shanks to the boring bar tip. Then again, you multiply that number by 2 because of diameter programming. By telling it this, the next move to Z0 would bring the stock out of the guide bushing 5 thousandths. So to bring the stock to 0, it would have to come forward out of the guide bushing 5 thousandths to bring it in line with the 0 of the gang tools.
Disc 2 finishes with the macro call G65.
It is written like this. The P8999 is the generic program this G65 is calling up. The letters after it are the arguments or variables that the person wants to pass into the generic program. In other words, he can control how the program works with this information. The G65 command is also called a canned cycle. In this example, A is the first peck.
Disc 3, with a runtime of 69 minutes, contains information on the G codes G76 through G999. It incorporates single-point threading with G76 completely dismantling its structure.
The first G76 line has 3 things on it, P, Q, and R. First, we will go through what the P stands for and the different digits behind it because there are 6 digits behind it.